I were to take the limit of both of these functions, this is what I would get. The limit as x approaches positive infinity of x squared minus the limit as x approaches positive infinity of x cubed. Okay, the x squared function is basically this way. So as I approach, as I go out to positive infinity, these values keep going up, so positive infinity. And the x cubed function looks like this. And as I go out to positive infinity, I also get positive infinity from my values. And here's the problem: we cannot evaluate infinity minus infinity. So let's change this. I'm going to factor out an x squared. And I want to break it into products as opposed to sums and differences. Okay, now let's take a look at this. This function is a parabola. And as I approach to the right, it's going to keep going to positive infinity. So this guy right here is positive infinity. Now, 1 minus x, that graph looks like this. There. Negative slope, y-intercept of 1. And as I go to positive infinity, I go to the right, it keeps going down, so it's going to be negative infinity. Okay, and we can multiply infinities. Infinity times infinity will be infinity, but I have a positive times a negative, so it will be a negative infinity. So again, it's unbounded going downward. Number 8, we're looking for horizontal asymptotes. For horizontal asymptotes, we have to look first to the right as x goes to infinity, see what asymptotes we have that way. And then we have to look to the left as x goes to negative infinity and see what asymptotes we have there. So we have to do this basically twice for the right and the left sides. So let's work on the right side first. Okay, so we want the limit as x approaches positive infinity of 5x minus 1 all over the square root of 4x squared plus x. Okay. First I look at my my denominator, and my largest power is going to be x squared, but it's under radical. So I'm going to take the reciprocal of that of 1 over x squared under a radical. And I can put one here as well. Okay, now my x is going in a positive direction, so I'm using positive values. And when you square those positive values, they remain positive. So in fact, let me use a 1 over x for the numerator. Rather than a square root of 1 over x squared. Okay, and now I'll distribute. And again, this is going to be positives, and this is going to be positives. So I have the limit. I don't need that right now. This is going to be 5 minus 1 over x. And this is going to be the root of 4 minus, or sorry, plus 1 over x. Okay. Furthermore, I want to take the limit of all these. So I have the limit of 5 plus, minus, should I say, the limit of 1 over x all over the root of the limit of 4 plus the limit of 1 over x. Okay, that should suffice. Okay, the limit of a constant function, 5 is a constant function, so it's horizontal. As you go out to positive infinity, will remain 5. The limit of 1 over x, as you go to the right, will become a 0. The limit of 4, which is a constant function, right here, as you go out to positive infinity, remains 4. And the limit of 1 over x as you go out to the positive direction will again be 0. So what we have here is a 5 all over the square root of 4, which will be 5 over 2. So this is the horizontal asymptote going to the right. Now let's look at the other side, what's happening at the left side. The limit as x goes to negative infinity of 5x minus 1 all over the square root of 4x squared plus x. Okay, so the highest degree in the denominator is a x squared with a root. So I'm going to put a 1 over x squared with the root as well. Okay, this will be a positive, even though the negatives are going, the x's are going in the negative direction, all the x's are negative. When they're squared, they become positive, and the root of positives is positive. So right now, this is all positives. Here I will use 1 over x. Now, 1 over x is using x's that are all negative, and so 1 over a negative number, it will be a negative number. So all of these right here are negative numbers. Sorry, the blue is so hard to see. Okay, so let's multiply those. What we'll get is a negative times a positive, which would be a negative 5. A negative times a negative, which would be a positive 1 over x. This is a positive multiplying within here, so we get the square root of 4 plus 1 over x. Now I'll start taking the limits of each one of these. So we have the limit of a negative 5 plus the limit of 1 over x over the square root of the limit of a 4 plus the limit of the 1 over x. Okay. The limit of a constant function is that constant, so this is going to be negative 5. The limit of 1 over x is going to be 0. The limit of a constant function is the constant function, 4. And the limit of 1 over x as x goes to negative infinity will be 0. Hope I said all these go to negative infinity. Okay, so as a result, we're going to end up with a negative 5 over the square root of 4, which ends up being negative 5 over 2. And that's going to be our horizontal asymptote. Why use that horizontal asymptote as we go to the left?